is finding the greatest common factor of two monomials. So a monomial just means that it's just one term. Okay, so a monomial can be it can be just a number, it can be just a variable, it can be a number with a variable. So we're going to go through all of those scenarios today. Okay, so the first thing, list all the numbers that can multiply to make 12. So we're going to list all of our factors of 12. So I'm going to make a little factor chart. I apologize in advance for my handwriting on this. It's going to suck. So our numbers that multiply to make 12 are 1 and 12, 2 and 6, 3 and 4. So these are just pairs. So 1 times 12 gives us 12, 2 times 6 gives us 12, and 3 times 4 gives us 12. Okay, now I put on Google Classroom links to two different graphing calculators that you can use online. So an option of how to do this, a trick that I actually have it outlined on the bottom of the page, is you can go into your y equals and type in 12 divided by x. Okay, then you would hit second graph, and that would bring you into your table. Now, when you look at the table, you're going to only be looking at the positive numbers, and you're going to start at 1. And anytime that you have a pair of numbers where both are whole numbers, I apologize for the squeaking in the background, that is my dog, I don't know if you can hear that. Anytime you have two numbers where they're whole numbers, that's what you're going to put on the list. Anything that's a decimal, do not include on the list. Now, as far as when to stop listing your numbers, so if we were to keep going in the table of values, we would, right after the 3 and 4, we would get 4 and 3. But 4 and 3 is actually just a repeat of 3 and 4, so you can just forget about that one. So that would be when you would stop in the table, okay? So that's how we would get the factors using the calculator trick, okay? All right, so now those are our list of factors for 12, and now we are going to do our list of factors for 6, okay? So the numbers that can multiply to make 6. So we've got 1 and 6, and 2 and 3, okay? So those are all, the 1 times 6 gives us 6, and 2 times 3 gives us 6. Okay, so now right below here, I just have why is this not clicking off? Hang on one second. I have the definition of factors, numbers that can be multiplied together to produce another number. So all of these numbers in the table are factors of 6. All of the numbers in this table at the top are factors of 12, okay? So now down here, are there factors of 12 that 12 and 6 share? So if we look at our two lists, we can see that both lists have 1, right? Both lists have 2. Both lists have 3. And both lists have 6, okay? So these are all the common factors that the two numbers have, okay? Now, what is the greatest common factor, or the GCF? So that's just looking at our list of common factors and finding the biggest number. So the biggest number in this list is 6, okay? All right, so that's how we get the greatest common factor of two numbers, okay? So greatest common factor, right down here, the largest factor that expressions have in common. And then below here, what I put was the kind of summary of what I talked about above as to just how to do this in the calculator to get your factors for your factor lists, okay? All right, so let's go to the next page, and we're going to do some examples. All right, so for each one of these examples, we are going to determine the greatest common factor between the two numbers, okay? So the first thing we're going to do is, for number 1, we're doing 24 and 28. Okay, so, oops, hang on one second. Still learning this program. Okay, So we're going to make a list of factors for 24. Okay, so we've got 1 and 24, 2 and 12, 3 and 8, and 4 and 6. Okay, so those are our list of factors for 24. All right, and now let's list our factors for 28. So we've got 1 and 28, 2 and 14. Now 3 does not go into 28 evenly, it comes out to be a decimal. And then 4 and 7. Okay? All right. So now let's take a look at both lists, and we are going to see, okay, who is the greatest common factor. Now first I'm just going to see who are our common factors. So the 1s, the 2, they both have 4, okay? So those are the numbers that they have in common, 1, 2, and 4. So the biggest one of that is 4. So our GCF is equal to 4, okay? That's it. That's all you have to do. That simple, okay? All right, let's move on to question number 2. So now we're doing it with 40 and 10. So we are going to list our factors of 40. So 1 and 40, 2 and 20, 5 and 8, and 4. Oh, I forgot 4 and 10. Okay, and now let's list our factors of 10. So 1 and 10, and 2 and 5. Okay, so we've listed our factors for each number, and now we're just looking for the biggest factor that both lists have in common. So we see that both lists have 1, both lists have 2, both lists have 5, both lists have 10. Okay, so the biggest number that both lists have is 10. Okay, so our GCF is equal to 10. Okay? All right, good. Okay, so let's do the next one. All right, so 54 and 45. So we start off the same way. Going to list our factors. So we've got 1 and 54, 2 and 27, 3 and 18, 6 and 9. Okay, so those are our factors of 54. And our factors of 45 are 1 and 45, 3 and 15, 5 and 9. Okay, all right, so now again we're just looking at our list to see who they have in common. So we both have 1s, both lists have 3s, and both lists have 9s. Okay, so our greatest common factor, the biggest one, is 9. Okay, the biggest number that both lists have in common. Okay, all right, now one more on these. So now we're doing 27 and 63. So our factors of 27 are 1 and 27, and 3 and 9. And our factors of 63 are 1 and 63, 3 and 21, 7 and 9. Okay, so now we're going to look at who they have in common. So they both have 1s, both have 3s, and they both have 9s. So the biggest number that they both have in common is 9. Okay, so our GCF is 9. Okay, all right, so that's how we do it when we are doing it just with numbers. Okay, so now we're going to talk about what happens when we're trying to find the GCF and we're dealing with variables. So let's talk about what x to the 5th means. Okay, so x to the 5th Now what that means is you're multiplying x 5 times. Okay, that's what the exponent means. That's the number of times that you're seeing the x, okay? So now we're going to rewrite x cubed. So x cubed, hang on. So x cubed is x times x times x. Okay, so 3 x's being multiplied together. So now we want to figure out, okay, well, what is the GCF of x to the 5th and x cubed? So here's what we're going to do. We've got this pair of x's in common, this pair of x's in common, and this pair of x's in common. Okay? So we have 3 x's in common from both of our lists. So what that means is that our GCF is going to be x cubed. Okay? Now something that is going to help you, because you're not going to want to have to write this out every time. So as long as you can remember that the GCF is always going to be whichever one has the lowest exponent. Okay? So every time you do a problem like this, and I actually summarize it up on the top of the next page, so for the rule for finding it with variables, you look for the common variable, so if they're both x's or both y's, and then you look for the smallest exponent. So the example underneath, find the GCF of x to the 6th and x, was that squared? So you don't have to write a whole thing out. All you have to do is take the lower exponent. So the lower exponent here is 2. So our GCF is equal to x squared. Okay? That's it. All right? So that's really all you need to remember. So let's go down and look at these examples. So for question number 5, you've got y squared and y to the 10th. So again, you're just taking the smallest exponent. In this case, is going to be the squared. So our GCF is y squared. Okay, that's it. Pretty easy, right? Not too bad. Okay. All right, now let's look at number 6, x to the 8th and x. Now, actually, the first thing I want to do right now on this one is I want to rewrite this with my invisible 1 as my exponent here, just so I see that it has an exponent, because I think sometimes we forget because it's not written in, but it's the invisible 1. So if you look at your two expressions, the lower exponent is going to be x to the 1st. So that is our GCF. You can write x to the 1st, or you can just write x. Okay? So that's it. That's your GCF. All right? Now, on number 7, well, the first thing I want to do before we get into anything, let's rewrite our 2 examples here, just so that I can fill in my invisible 1s. Okay. So now, when you have a situation like this, where you have more than one variable going on, you just take it one piece at a time. So if we look at the x squared first, you'll notice that we don't have anything in the second guy that has an x. We don't have any other x's. So a common factor cannot be x. So if the variable is only in one of the terms, then it's not part of the GCF. So don't worry about the x, okay? Now let's just focus on the y's. So you have y to the 1st and y to the 1st. Well, they're the same exponent, so the lowest one is just going to be 1. So your GCF is y to the 1st, which is equal to y. Okay, I know that's a little weird when you're dealing with more than one variable, but we're going to be doing more problems like that right now, so I think it'll make a little bit more sense. All right, so now it's a to the 4th b cubed and a squared b squared. So one piece at a time. Let's first focus on the a to the 4th and the a squared. So you just take your lower exponent, which is a squared. Okay, now we look at the b's. So we've got b cubed and b squared. Take the lower exponent, b squared. This is your GCF. You just put them next to each other. That's all. One piece at a time. Just focus on the A's and then focus on the B's. That's all you got to do. Okay? All right, now let's look at number 9. So now number 9, we have x to the 8th and y cubed. So now these are totally different variables. They don't have anything in common. They're completely different. And that's my dogs barking. So hold on one second until they stop barking. Okay, I apologize for the interruption. So just keep in mind that both of these guys have invisible ones in front, okay? Now, that means then if the variables are totally different, then the GCF is just going to be 1, okay? If they're completely different, the GCF is just 1, okay? And that holds true for whether it's variables or numbers. If they have nothing in common, the GCF is just 1, okay? All right, so now on number 10, so now I've thrown some numbers in here, or coefficients, along with our variables. So we've got 4x to the first and 2x to the first, okay? So let's first just figure out one piece at a time. So let's first look at the 4 and the 2. So our factors of 4 are 1 and 4 and 2 and 2. And our factors of 2 are 1 and 2. Okay? So we look at our lists and we just want to see what is the biggest number both lists have in common. They both have 2. That's the biggest number. So the first part of our GCF is just 2. Okay? Now, we need to focus on the x's. Now you've got x to the first and x to the first. They have the same exact exponent. So then you just tack on x to the first. Or you can just write it as x. So you can write the GCF as 2x to the first or as 2x. Okay? All right. So just a few more examples to go. And now, if at any point anything in what we're doing right now is confusing, please email me. Send me a message on Remind. We can do a Google Zoom or Meet or one of those things, and do a video, lesson. Okay, I mean we can meet and talk about it. So please do not be shy. Okay, I want to help you guys. All right, so now let's look at number 11. We've got 12y squared and 6y cubed. So let's first just focus on the 12 and the 6. So our factors of 12 are 1 and 12, 2 and 6, and 3 and 4. Okay, now let's look at our factors of 6. So we've got 1 and 6, 2 and 3. Okay, so that is our list of factors. So we're going to look and see what the biggest number is that both lists have in common. So both lists have 1s, both lists have 2s, both lists have 3s, and both lists have 6. So our largest number that they both have in common is 6. And now, so that's the numbers. We dealt with the numbers. Now we're going to focus on the variables, the y squared and the y cubed. So we look at the lower exponent. So the lower exponent is y squared. Okay, and you just tack the two together. There you go. There's your GCF. Okay, just deal with the numbers first and then deal with the variables. Okay, all right. So on the next one, so now we've got coefficients, we have numbers and 2 variables. So we've got like 3 pieces going on here. Just keep in mind that with the 6xy to the 5th, that there's that invisible 1 exponent by the x. Just keep that's a 1 right there. All right, so let's list our factors of 6. So 1 and 6, 2 and 3. And our factors of 2 are 1 and 2. Okay, and the largest number that both lists have is 2. So that is the first part of our GCF. Now the second part, so now let's just focus on the x's. So we have x to the first and x cubed. Just take the lower exponent, which is x to the first. Okay. Now let's focus on the y's. We've got y to the fifth and y squared. Take the lower exponent, y squared. There you go. Okay, that's it. All right, you guys are doing great. Okay, 2 more. All right, so number 13. We've got, let me see, 24 and 36. So let's list our factors of 24. So 1 and 24, 2 and 12, 3 and 8, 4 and 6. Our factors of 36 are 1 and 36, 2 and 18, 3 and 12, 4 and 9, and 6 and 6. Okay? All right. So looking at these two lists, the biggest number that appears in both lists is 12. Okay, so that's the first part of our GCF is 12. Okay? So now that's the numbers. Now let's focus on our a's. We have a cubed and a squared. Lower exponent is a squared, so just tack that on. Now if you look at the next part, the b squared, there is no b over here in the 36a squared. So that means that there's not going to be a b in the greatest common factor because they would both need to have the b. So you're done right here. This is your GCF. Okay? All right. One more. Okay. All right. So we've got 22m to the fifth n cubed and 11m squared n to the fourth. So our factors of 22 are 1 and 22, 2 and 11. And our factors of 11 are 1 and 11. So the largest number that both lists have is 11. Okay, so the first part of our GCF is 11. Now we're going to focus on our variables. So we've got m to the fifth, m squared. So our lower exponent is m squared. And then we focus on the n cubed and the n to the fourth, and our lower exponent is the cubed. Okay, and that is our GCF. Okay, all right, so that's it for this lesson. I have some practice questions posted on Google Classroom that I'd like you guys to try. When you're done with them, you can take a picture of the worksheet, or if you do your work on a separate piece of paper, that's fine. Just take a picture and then either send it to me on Remind or send it to me through my email through Google Classroom. All right, guys, thanks a lot. Okay, bye-bye.